Okay, here we are again. And I now have Michael with me, and he is going to tell you more about databases in the cloud, I believe, this time, yes?
Yes, that's correct.
Yes, okay. So without further ado, oh, actually, let's just make sure you are all joining me. Yeah, I can see 50 people are here. And if you guys could just, again, confirm in the chat that you can see and hear us, we will get going. Yep, Matthias is my man. He always tells us we're here. Okay, here we go. It's over to you, Michael.
Thank you, Heather. Okay, hello to everyone, and welcome to the third day of LiveCode Global, and this is coincidentally the third part of the databases talk. It's actually a really beautiful day here in Edinburgh. And I know us Brits tend to go on about the weather, but this is actually something to talk about. A beautiful day in Edinburgh doesn't really happen that often. We're certainly not in the middle of August, surprisingly. Anyhow, let's get on with the talk now. If you remember from the first two parts, we created a local database app using SQLite, and it was a simple notes app. So I'll just go over and share my screen, and we'll go over with our app, what our app looked like from the first two sessions. Excuse me while I share this. Face, so it's a bit more functional or a bit more usable. Previously it was kind of good for showing you around and showing you how everything worked, but now it's been tidied up and rejigged a little bit, so it kind of makes a bit more sense as an app. So you might remember you could create a note. So if you click on the new button here, it creates a note. Each note has a title and a body. Tick button. And there we go, we've got our new note. This is displayed in a data grid. So you remember we had a single notes table which stored all our notes. Each note had a title, a body, as we mentioned, and an edited date, a created and edited date. You can see that there. And that was our simple notes table. And if you remember, it was an SQLite database that was created on the app's startup. So each time the app started, it created a brand new notes.db database. This location was dependent on the platform. Here, when we're running on the IDE, it creates it next to the script, the LiveCode stack rather. So it creates that on startup and populates it if it isn't already there. So we notice we've got our new note populated in our present in our data grid. We can double click on the note and edit it. So we can maybe add a little bit more to our body. And we can, oops, easy. And we can click tick again, and that will save it. And there it is, updated in the database there. And another thing we did to our notes was we added the ability to add attachments. So let me just take a little screenshot here. And I'll add that to our note as an attachment. There we go. Anytime. There we go. So we've got there, we could add a couple of attachments. So, add our second attachment there. And there's our first and second attachments there. Save our note there, tick. And there we go, there's our new note, and there's the attachments there on it. So we did the attachments we implemented the attachments by creating a second attachments table and then mapping each attachment back to an original note. And then the final thing you remember we did was create categories. So we create a new category here. Let's create a red category and a green category. If I could spell and type, it would be better. And then if we create another note here, notice we've got our category. So let's add a red note, red button there. Then we've got a red note, and then we can filter all the notes by a given category. So those are only our red notes. And we can have a green notes. We have no green notes. We can return all notes. And then one of the last things we did was the searching. So we can search, maybe say by title. And that will return any note which has title within the text of the notes title or body. So there we go. That's our simple notes app. And that's what we created in the first two parts. And just to reiterate, this was a local-based database, so the database is an SQLite database stored in a file right next to our LiveCode stack. So this part of the talk, we're going to go on to moving the database into the cloud. Now, I guess the first question is, why do we want to move our database into the cloud? Well, the cloud provides a central location to store all the data that we want to have in our database. So that means that can be accessed from any location, and all the same data will be accessed. So what that means is that you can maybe access the database from your phone, from your tablet, from your desktop, and rather than having an individual local database next to your each individual apps on those 3 devices, it contacts the cloud, and you've got the same notes shared across all your 3 apps. Maybe you want to go on holiday or something, you've got a different device, then you can see your same notes from that device overseas without having to create a whole new local database and copy all your notes from one to the next. So that's why. So let's see how. So if you remember from the last time we talked about the structure of our app, you'll notice our sort of 3 layers there: our user interface, then our database library. That's where we abstracted all our database commands into a sort of single, nice, easy to use library, and then had that talk to our FDB, which talked to our SQLite database. Now, the last thing we talked about last time was introducing an intermediate data layer. So I'll quickly go here. So you notice the data layer there sits in between the user interface and libdb. Now, by introducing this intermediate data layer, that creates an abstraction. So what this abstraction is the user interface no longer cares about how the data is stored, whether it's stored in the database, whether it's stored in text files, whether it's stored locally, or whether it's stored in the cloud. All it cares about is how it talks to the data layer. The data layer has a simple API, and our user interface just talks to the data layer. The data layer then talks to the actual database itself. Now, why do we want to do that? Well, it means that the data can be stored in any way we want, and we don't really need to change the user interface. So, for example, our local-based app, we can have exactly the same user interface as we had before. We have the data layer, libdb and revdb. If we want to move it to the cloud and have our server-based database, well, we have our user interface talking in exactly the same way to the data layer, but this time the data layer, instead of talking to our local SQLite database, it instead talks over HTTPS to our web service, and then that in turn goes through libdb, revdb into our MySQL database. So that means that our user interface in our same app essentially remains exactly the same as before for our local one, but instead we're talking to a different data, or we implement a different data layer, which in turn will handle with communicating with the web service. So all we need to do is change the data layer. We don't need to change our user interface. It's all nice and neat and simple. So you'll probably notice there, HTTPS, that's the bit in the middle. So let's kind of take a little sidetrack and ask, what is HTTP or HTTPS? Well, HTTP is essentially how your web browser fetches a web page. It's a communication protocol, which is the foundation of World Wide Web, and it's essentially a simple language that allows a client and a server to communicate. So, for example, when you fetch google.com, the client is your web browser and google.com is the server. The client sends a request, the server sends a response. So each request and response is made up of a header and a body. So, for example, when you're fetching google.com, the request header will say, I want to fetch google.com. That tells Google server what you want to fetch. But you have nothing in the body will be empty, and then google.com will return a header and a body, and the body will contain the content of the web page, and the headers that contains any extra sort of meta information. Another example is maybe when you type in a search string. This time, the body of the request will be the search string that you sent. So you're uploading that search string to google.com. It then parses that and returns the information. So that's an example of HTTP. It's a language that the client, your browser, used to communicate with your server. Equally, liburl, which is part of LiveCode, that implements HTTP. So that liburl takes care of creating the HTTP request. It builds the headers, it builds the body, and then sends the request off to google.com. So an additional part of HTTP are the verbs get, post, put, delete. There are a few others. Get and post are the most common, and these verbs are part of the HTTP request header. So you're sending a get request or a post request. So get is when you essentially fetch a simple web page. There's no real extra information there. But post is maybe when you want to post some information. So you're filling out a form, for example, signing up to a website, logging in, or entering your payment details. That information is posted to the using the post HTTP verb, and that information is sent out in the request body. So as I say, though, the verbs are stored as part of the HTTP request header. And so you're probably familiar with this, but this will show you how you can use get, post, and the various HTTP verbs in LiveCode. So get URL, that's a simple get request there, and the response is in it, so you put it into the LiveCode site. As I mentioned before, liburl takes care of all the hard work. It takes care of communicating and formatting the HTTP request, builds headers for you, builds a get verb into the header, so it deals with it. And this is exactly the same thing. The second part here, put URL https://livecode.com into TLiveCode site. Although it's using put, don't be confused there. It's still a get request, put URL into a variable, so it stores the contents of livecode.com in our variable key LiveCode site. Next bit is post. So you can see the second line here, post email equals michael@livecode.com, password equals testing, to URL http livecode.com sign up. So that maybe creates a new user, Michael at livecode.com with the password testing. And you notice here, the first line, set the HTTP headers. I'm telling LiveCode to use a particular header here. This is just a little bit of extra instruction to the server, livecode.com, that the user agent we're using is our LiveCode sign-up app. And the response from the server is stored in the it variable. Like when we used get previously, it's stored in it again. So that's the response of the sign-up process. The next bit is put and delete. As I said, these two are a lot less common. Post and get are the two main ones, but put and delete do exist, and they're part of the LiveCode liburl as well. So if you want to put, you use put and password equals new password into URL http livecode.com users Michael. So this example might be updating my password. And so put, send that form to part of the request body, password equals new password. And this time the response is in the LiveCode property, the URL response. Notice here I'm also checking the result. The result is part of both post and get requests. And that will tell you whether there's been a server error. For example, you've probably seen 404s or 500 server errors, and page not found, or the server's misconfigured. If that happens, the result will not be empty, and the detail of the error will be stored there. And finally, the last one is delete URL, https livecode.com users Michael. Now this doesn't actually delete files on the server, but the actual action is determined by the server. So in this case, it might delete a user from a database there. So it might delete the Michael user from the database. So that's sort of a brief rundown of HTTP, but that's all very well and good. But how does this help us in our cloud app? Well, if you remember our little app breakdown or app diagram, we communicate with the server using HTTP. So we build a web service API that is based on HTTP and handles our requests. So you remember one of our data layer commands or function in this case was fetch note. So this returns all the notes in the database. And we can maybe do this is just an example of how it may be done by getting the contents of the URL api.notes.com and then specifying an action equals fetch notes. Now you notice here question mark action equals fetch notes. These are parameters that you can pass in get requests. So this is still a get request using the get verb, but we're setting an extra parameter, and this is telling our web API that we want to fetch the notes. Now for the moment, just ignore the how this works in the server side. I'll come to that in the later part of the talk. We're purely just considering a very basic client side and creating a basic server-based or cloud-based API. So the notes that are returned by the server are put into T notes, and these are contained within the server's response. So the server-side scripts will see the action equals fetch notes. It goes to the database, pulls out all the notes, and then puts the notes into the body. Another example might be creating a new note. This time we might want to post the contents of our note. So notice here, we put title equals %s, body equals %s, and we're using URL and code. Now, URL and code is important here. All information that you're going to post to the server in this format, key equals value, in this case title equals so on, body equals so on, need to be URL encoded. That removes any, or escapes any sequences of characters which are going to confuse things, spaces, for example, or equally the ampersand symbol that might confuse things. Those get replaced with percent encodings, which are then handled by the server. So now we post title equals our new title, body equals our new body, to api.notes.com, and this time the action is create note, and this time the server will see that the action is create note. It will create a new note in our database and return if that succeeded or failed. So that's kind of a very simple web API that we can implement on our server side. But a more common way, or a more modern way, are RESTful APIs, which you've probably heard of, and there's quite a few talks on about it today. Mark's got one, and I believe Greg is also doing a talk on RESTful APIs as well. So what are RESTful APIs? Well, they stands for Representational State Transfer, and it's a standard way, a modern standard way of specifying web-based APIs. Now, all the requests are stateless. That means each request is independent of another, and it uses the HTTP verbs and server-side paths to build or to sort of specify that API. Now, I'll come on to a little bit more detail later, but an example might be sending a GET request to livecode.com/users. That will return a list of all the users, and sending a GET request to livecode.com/users/Michael. That will return a specific user. So you notice the path there, users and users/Michael, that's used to specify our API. That's how we get individual parts of the database in this case, in our case. So let's have a look at our data layer, and let's look at the handlers that were there before. So we had create note, fetch note. Those are obvious. Fetch notes, that returns a list of all the notes. Search notes, that search for specific notes. Filter notes by category as it suggests. Get all the notes in a given category. Update a note, create a category, and fetch the categories. So that's our data layer, and we want to convert that data layer into a web-based API, a REST API. So how would we do that? Well, I guess the first thing is to consider create note. So here's our server, api.notes.com. It's just an example address, /notes. If we post any data to that, that will create a note. So that's lib data layer create note. Then we do that by posting to https:/api.notes.com/notes. We post the data of the note that we want to create. That's sort of like the example we had previously, where we posted the note title and the note body, and that gets handled by the server. Equally, the three sort of fetching notes, where we fetch a given note, we search for particular notes, or we filter the notes by category. We can do that in exactly the same way, api.notes.com/notes. And this time we add the question mark parameters, the get parameters that I talked about earlier, where we pass, if we want to search for a note, a search string, and if we want to filter by a specific category, the category. Next is fetching a particular note. So again, like I mentioned earlier, we build the path on the server to specify the given note that we want to fetch. So this time notes/ID, where ID is the note of the ID of the note that we want to fetch. And this is again a GET request. And if we want to update a particular note, well, the path is exactly the same, notes/ID, where ID is the ID of the note we want to update. But this time, instead of using the GET verb, we use the PUT verb, and that updates the contents of the given note. So GET request to that path returns the contents of the note. PUT request to that path, well, we put the data into that note, so we update the note. And then the final part of our data layer was categories, and that's exactly the same. We have our categories, path and get request to /categories gets notes and post to /categories. Well, this time we're posting data into that, so that will create a brand new category. So that's marked to a data layer fetch category and data layer create category. So I touched on this briefly earlier, but when you're passing data between the app and server, there's a few things that you need to take into consideration. First of all, we need to URL encode all the get parameters. So back here, get parameters are an example here, $search equals the search term and category equals the category. We can make sure those are all URL encoded so that the information is properly escaped and handled by the server, rather than getting a little bit confused with one character, possibly your search string contains ampersand or something like that. So that means that all the characters are properly escaped. And then with the request and response body, well, this time we need to determine how we want to pass the data to the server. So if we go back here, when we're creating a note here, for example, we're posting to libdata create note. We're posting to api.notes.com/notes. We're posting data, but what format is that data? Well, the simplest way, and the way that I showed earlier, was in key value pairs. So title equals ampersand body equals, and the server parses that. Now that works pretty well, but it's a little bit limited. You can't, maybe you want to specify more complicated data that's a bit more than just key value pairs. For example, we used nested arrays, which are more than just key value pairs, they're subnests. That then becomes a little bit complicated using simple key value pairs. Another option is to use XML, and that works well, but it's a bit bloated and it's a bit of a faff to set up. You need to use RevXML, and it's often more complicated than it really needs to be. A nice way is to use the array encode and array decode. So for example, say we want to format our note as a nested array. So the first element is, we have a title element, we have a body element, and then we have a subarray of attachments and a subarray of categories. We can just use array encode. The array encode function within LiveCode takes a LiveCode array and serializes it into a binary string that gets posted up to the server, and the server side then runs array decode, and that decodes that binary string back into a LiveCode array, and that works nicely. And that's a really good way if your client and your server are both implemented in LiveCode. So as you see, that's maybe not so portable. Now it's fine if it's, as I say, a LiveCode app, both in client and server side, but you might be come into contact with third-party APIs which are written in another language, and they'll probably use a more standard format, and that could be XML, it could be key value pairs, or more commonly these days, JSON. Now JSON is just a way of encoding data, exactly the same or very similar to array encode and array decode, but it's kind of slightly human readable. And within LiveCode we have the functions JSON to array and array from JSON, and that will do exactly as they say, convert a LiveCode array to JSON, and from a JSON blob convert that back into a LiveCode array. So when you send data to the server, you'll call array from JSON to array. Array from JSON, and then on the server side you'll call JSON to array, which will decode it back to that should be array to JSON and JSON to array, excuse me, that's why I was confusing myself. So array to JSON will take a LiveCode array and encode it into JSON, and JSON to array will do the exact opposite. It will take a JSON blob and convert it back to a LiveCode array. So on the client side you'll run array to JSON, and on the server side you'll run JSON to array, and that will make sure that you've posted all the data up correctly, so the server then sees that you want to create a note with a given set of attachments, a given set of categories, and a title and a body. The final part to be aware of is make sure that you encode in base64, encode any binary data. That just alleviates any problems that you might get with binary data in URLs. It's not strictly necessary, but it's good practice, and will stop you getting tripped up later on. So let's see, now we've kind of specified our API. How do we actually use that? Well, let's consider fetching notes. Now remember, that was a GET request to api.notes.com/notes. So here we do, put URL notes.com, api.notes.com/notes, entity response, check the result to make sure that the result is not empty, and to make sure there's no error occurred. And then you notice I'm using this function libURL last RHH headers. That tells that gives you the headers that the server sent back. And one thing that the server can send in this, the headers, is the content type header. That basically says the data that we're sending back has been JSON encoded. So if the content type is application/JSON, then we know that the server's given us JSON data, and we need to convert that data back into a LiveCode array, which we then return back to our UI. So the data layer API here, libDataLayer fetch notes, that's exactly the same as it was with our local app, but in this time, instead of querying our SQLite database, this time we call a URL to get the contents of the cloud database, decode that contents, and return it. So the UI doesn't know any different. For all it cares, it could be a local database, it could be a text-based database, it could be an XML database, it could be a cloud database. All it's doing is fetching, calling libDataLayer. And then the final part is creating a note, or the final part that I'll show here is creating a note. Now remember, I mentioned before, it's good to base64 encode all our binary data. So in this case, these are our images or attachments. So make sure we base64 encode. Then build our array that we want to pass to the server. So we put our title in the title field, body in the body field, our array of attachments into the attachments, and our list of categories into the categories field. Then make sure we encode our array to JSON, and then build a request body, put that into our request body. Notice that we're setting the HTTP headers property. This is exactly the same as we've seen previously, but this time rather than the server telling us that we're receiving JSON, we're telling the server that we're sending JSON. So we're setting the content type to application/JSON, and then post that up to the server. The URL is exactly the same, but this time instead of being a GET request, it's a POST request. Check result, and then if all's gone well, return the empty string to let our UI know that everything has worked as desired. So that's how we create a note, and that's how we fetch a note. So let's go back to our app. Now here's our local app, and you'll notice this is our libDataLayer stack here that we had previously. So let's see, create note. This does very similar to our previous function, but this time it calls libdb insert, i.e. it's inserting into the local database. Now if I go over to here, this is our cloud-based app, and this time if I go to libDataLayer create note, instead of calling libdb insert, it builds our array like we had before, but this time it sends a post request. Now you'll notice that I've abstracted all our HTTP requests into a sort of nice little handler. So we specify the request type method, so that's get, post, put, delete. So if we go back to create note, we call send request, post request. This is a path. Path is just notes. The request body, that's the data that we want to post. And then the final parameter is any get parameters that we want to send. So that's that's any kind of parameters that are part of the URL, remember, question mark. Now I've got our server APIs, unfortunately not api.notes.com, but it's hosted on my OnRev account for our example. First thing it does, as I mentioned before, we URL encode all our get params. So get params are just an array. We've not got any in this case. These are put into part of the URL using the question mark, so that's the final part of the URL. The previous part is our michael.onrev.com/LC global, and then ppath. So ppath in this case is notes. So our request is michael.onrev.com/LC global/notes. Next thing we want to do is, if the body data that we're posting up, in this case we're posting the note we want to create, is an array, then we want to make sure that our array is properly encoded. So we call array to JSON, and also set the HTTP headers to application/JSON, telling the server that we're posting up JSON data. And then the final part is the actual sending of the request. So in this case, get, post, put, delete. Here we're using a post request, post it there, check the result, and then put the response into tResponse. If the result is not empty, i.e. we've encountered an error, throw that error, and then we'll handle that in create note in the try catch block here. And then, oops daisy. And then the final part is decode the contents or the response sent by the server. And like we did before, we use libURL last RHH headers, put that into our response headers, and then check to see if it's JSON. In this case, if it is JSON, then put that back to an array. And then return the response. Now the content type could actually be anything, and in theory we could check the content type, so it could, instead of being application/JSON, it could be application/XML, in which case we might decode XML. It could be, as I mentioned, LiveCode arrays, or serialized LiveCode arrays, in which case we'll call array decode. But for now, we're really only considering JSON. So let's see how that works in our little app. So there, this is our cloud-based app. Click New. Remember, our UI is completely unchanged. All that's changed is the web data layer. So let's create a note title. And then click. It should create our new note, and there's our note there. We can now edit our note. If I double click, hopefully. Should do. Let me check. Oh. Try that again. API error appeared to frozen. Let me restart LiveCode here. Sure, wrong there. Okay, here's your note. Now if I double click on it, hopefully it should allow us to edit it. I'm not entirely sure what went wrong there. I think our internet connection is a little dodgy with performing a webinar at the same time as everything else that's going on in the office. So we can edit our note, click tick, and that should hopefully then show our edits. And we can do exactly as before, create a new category. And that should appear in the list of categories. Give it a second to update. Oops. I think our internet connection is somewhat slow up here, unfortunately. Let's see if it's working. Oh, yeah. So we've got an error here which I've not handled properly, which means that the previous request was still executing, which is, yeah, means that I'm not handling the errors properly in our data layer library, which is my fault because I didn't take care of the errors all correctly. Which means that I'm just blindly returning the result here rather than actually handling the case where so when I'm fetching the categories, you can see that I'm returning key error rather than actually handling the error correctly. In this case, I was sending two HTTP requests simultaneously because our office Wi-Fi is a little slow up here. But you kind of get the basic picture. Let me restart our app. So let me see it here. So yeah, we can see that our red category is now there. Had I waited properly, it would have been there. So we now can create a new note and our red category will be there. And similarly, we can attach images and assign categories and search like we did in our cloud and our local app. So let's go back to our slides. Where are you? And let's see, what do we need to do to actually build our server-side API? Well, the main thing we need is a server. And actually, in this case, I'm using my OnRev account, but it could be Google Cloud, Amazon Web Servers, any kind of third-party hosting service provider, or you may indeed have your own dedicated server, in which case you can use that. You need to use a database. It could be MySQL, Postgres, SQL Server, anything really, as long as it's an SQL database and it's installed on your server, then it'll be fine to run with LiveCode. And finally, you need a scripting language to actually do all the work server side. Now, it could be PHP, Java, Ruby. There's several that are out there now, but in our case, we'll use LiveCode, which means that we can use exactly the same code on our client app as we did in our server app. So let's see, how do we create our database? Well, the first thing is it can't be done dynamically like we did with our SQL-like database. When we did on startup, we created it dynamically. That's really, the server doesn't allow that kind of thing. You need to kind of create one database, but you create a database and configure it once for all users, and it's accessed by a username and password, and the schema will need to be tweaked for each database type. So we had quite a specific we had the schema specific for, if you remember our schema from before, it was specific for SQLite. I've tweaked it slightly, so now it works with MySQL. The tweaks are minor. Most bits here are the primary key and varchar types, which are specific to MySQL, but the basic schema is exactly the same. So what I'll do is I'll quickly show you how you can create a database using your OnRev account, if you happen to have one. When you log into OnRev cPanel, this is what you'll see, and you can click on MySQL Databases. I'll create a new database. My OnRev account is called Michael, so all databases that I create will be prefixed with Michael underscore. I'll call it RESTful Global, RESTful Global. Create that database. Next thing we do is we need to create a user. Scroll down. I'll call the user exactly the same thing. And I'll just let it generate a password for us. Do that for later. And we'll now create the user. And then the final part of the puzzle is to map the user to the database. So we give our new Michael LC Global user access to the Michael LC Global database. So we add that user. We need to give them all privileges so they can create tables, they can insert tables, they can delete records, and so on and so forth. Make the changes, and there we go. So now we have a brand new LC Global database. Next thing we need to do is pre-populate our database with our database schema. So clicked on the PHP My App, and that's a simple way to see the contents of your database. And then what I'll do is I'll get our schema. First thing I'll do though is password so I don't forget it, and then I'll copy this. So that's our database schema. Then the left-hand side here, you'll see my new LC Global database. There's nothing in it at the moment, so if I click on SQL and run this list of SQL, go. And here we see our tables, our attachment table, our categories table, our notes table, and our table which maps notes to categories. So that's the first part. We've created our simple server-side database. So now we've got our server-side database, the next thing we need to do is start developing our app. So we need to set up our API. Now you remember the RESTful APIs, they're all path-based. So typically when you create a website, each individual path is handled by a specific file. So do we want to create a specific script for each path, or what about dynamic paths? These are ones which change each time. So those are ones which have, like, for example, the ID of our notes. That's going to be different for each note. We can't create a file for each individual, a file on the server that will handle that path for each individual note. That doesn't really make any sense. But what you can do is configure all requests to a given directory to point to a single file. Now, this is going to be specific to the type of server you've got. OnRev runs using Apache. So Apache, you use the htaccess file. Now, I won't go into too much detail into this. It's specific to each server, and really it's kind of one thing you write once and then never care about it again. But what this little blob of code here does is redirects all the requests within the given folder that this file exists to api.lc. So that means that we just need to write a single server-side script that will exist in api.lc that deals with our web-based API. Now, if you remember our little server structure before, this is our server side. The top layer we have our web service. That will be api.lc, that's our LiveCode script. Sitting below that is libdata layer, and it's libdb and revdb. Now, the nice thing about using LiveCode is this is all written in LiveCode server, and our libdata layer, libdb, and naturally revdb, those are all exactly the same as our data layer libraries and our database libraries that existed for our client-side app. So these are completely unchanged. This time, instead of executing locally though, they're executing on the server. And the only real change we need to do is tell libdb to talk to a MySQL database rather than a SQLite database. So a little bit about LiveCode server programming. I'll show you an example in a second, but all LiveCode server files have the .lc extension, or typically the main files do. You can use LiveCode stacks using the start using command, but main ones have the .lc extension. And you put LiveCode scripts within this angle brace $LC blocks. I'll show you what that means. And they're just text files with LiveCode script within them. You can include subscripts, or essentially our library scripts, using the include command. So that allows us to include our data layer and our database library just using include. And the scripting language is absolutely identical to the LiveCode desktop programming language, which is a great bonus for us because it means we have to do very little to get our client app, our local app, up into the cloud. So let's have a look. Here's our htaccess file. The way you get that up onto the server is using FTP. This here is FileZilla. It's an FTP client. There's several of them around, and you can use your own one. And I've got my htaccess file here locally. I can then upload it using FTP, using FileZilla, to our LC Global, my OnRev server in the LC Global subdirectory. And then I've already uploaded that and our api.lc file. I mean that all the content is redirected to api.lc because of our htaccess file. Now let's have a look at api.lc. I include a library called RESTapi.lc using the include command, as I mentioned. Notice the question mark, angle bracket question mark LC. That means that this is a LiveCode server script. I also include our data layer, which our data layer is a sub-library. This is in the libs folder there. Let's just quickly go to our data layer. You'll notice that our data layer is the functionality here is exactly identical to our local lib data layer. The only difference is this little line here at the top. We connect to a MySQL database on localhost. So we created our one. We created our database. This is the database name. LC Global. LC Global. This is Atom that's throwing these errors, which is rather annoying. Needs updated. Our database name is LC Global. Our username is Michael_LC Global. And our password, we copied and pasted that before over here. So we'll copy and put our password in. So that's as simple as it is to connect to your database. Save that, and if we want to upload that, go to libs, and then upload our data layer, which is now pointing to our LC global database. So as I mentioned before, our data layer here is exactly the same. So the way you access a database on the server is exactly the same way you access a local database. We're just using our database library, calling libdb insert, libdb fetch array there, libdb update, and so on. So that's completely unchanged. As is libdb. Libdb is exactly the same as the local libdb. So that's a great advantage of using LiveCode. Nothing here has changed. So let's go back to api.lc. Now, I created a simple REST API library. What this does is, rather than having to go through and parse each individual path, which is stored in this variable here, $_get_path, we can register handlers for a given path. So it's pretty simple, and it just makes things a lot more easy and convenient. I won't go through how it implemented. I'll upload the code and you can see there, it's fairly trivial. But what this does is, I'm registering handler create note for path notes when the HTTP method is post. Equally, I'm registering the handler update note for the path notes /star. In this case, star, that matches to anything. So this is when we're updating a note. If you remember, the update method was put into URL notes /123, where 123 is the ID of our note. Similarly, fetch note is when you call when you send a GET request to the same URL, so notes /123, that will get the content of note 123. Fetch notes, that's just the path notes, and the GET request. Create category is post to the categories path, and fetch categories is get to the categories path. And then what we do is call handler for path. So basically all that does is looks in this method here, command rather, looks for the list of handlers that have been registered and calls the appropriate one for the given path. So in this case, create note is an example, and it calls it with 3 parameters: the path parameters, the get parameters, and the actual body. And all we do with the create note handler is call lib data layer create note, pass the body title, body, and body attachment, so the list of attachments and the list of categories to our lib data layer, and then return the result. So it's exactly the same as we had in the servers on our client side app. This time though, we're just sort of going through this little REST API intermediate layer. Update note is exactly the same. Notice this time though, we're using path params #1, so that's what maps to this wildcard character, gets put in the first parameter. If you have several wildcard parameters, then the second wildcard will get put in path params #2. So in this case, path params, the first param is the ID of the note, so we put that there, and then we take the title and the body out of the request body. And if you remember lib data layer, update note, you pass the ID, the title, and the body. So that's as simple as it is to build our REST API. This little REST API library that I've created makes it really easy. Rather than you having to go through and parse the path by hand, it just deals with it all for you, and you can just register handlers for given paths. So let's see if I can close down LiveCode.
Just a little mention, Michael, that you are very close to time here. So.
Well, we're pretty much done in this regard, because that's showing pretty much everything that is involved in creating a cloud app. So I'll now load it up. So this time we should be pointing to our newly created database. So I'll show you what happens when we create a note with our new database as LiveCode starts up. Hopefully it will start up eventually.
While you're waiting, there's a couple of little questions you might want to consider here. Devon has asked, I might have missed something. Where is, hang on, REST API register handler for path and method defined? Uh-oh. I think we actually might have lost my... Yeah.
A simple library. It's not that long, but all it does is register. It sort of builds an array of all the handlers that you've specified for the given paths and the given methods, and then call handler for path parses through that array and looks for the handlers, and if it finds that handler, it calls dispatch to call it with the various parameters that are there. I won't go through exactly how it works because we're running out of time, but it's, as you can see, there's not too much to it. It's fairly straightforward, and it makes building REST APIs a lot easier rather than having to go through by hand and parse the path. You can just register handlers for the given path. You
might want to turn your video back on as well.
Oh, you may turn. Oh, sorry. You go back.
There we go. Okay.
Another question?
I think there was another question. Let me just look back down here. I'm pretty sure Jonathan asked, how can we use LiveCode Server to interface with a web-based database that serves millions of users and millions of records?
To use LiveCode Server? Well, you can do exactly the same thing as we've done with our local and client app, our local and cloud app. So you can call, if that's a third-party database that gives you access to it, it will probably have an API that gives you access. So it will have probably a REST API, most commonly these days. In exactly the same way as we've created an API, we can then call somebody else's API, and we can do that directly from LiveCode Server in exactly the same way we've done with our local app here by calling put URL, get URL, post into URL, and so on. That's so that means that you can, REST APIs are a standard, and you can call them from anywhere, from local apps or the server as well. So, for example, if you want to do it server side, you can call a REST API that's developed by third-party clients. And the good thing about that is because it's a standard, you don't really care how it's implemented. As long as you can access the API with the given credentials, you can call it from LiveCode Server. So if it's written in PHP, Ruby, or whatever, you can still call that API from LiveCode using the get URL, post URL commands.
Cool. So Arthur is asking, can this be generalized and wrapped as a generic cloud framework?
Yeah, so that if you want, that's certainly possible. The main thing is the main two parts that are probably reusable are that little handler that I wrote in Web Data Layer, which called, which sort of abstracted the calling of remote handlers. So if you remember, you passed the method post, you passed the path that you wanted to call, and then the contents that you wanted to do that. You could reuse that within your own app. And then the final part that's probably most useful is if you want to build an API. Sorry, I'm realizing I'm not sharing my screen anymore, but if you want to build an API, you can use that little REST API library that I wrote, and that will allow you to create a REST API to your own specifications in exactly the same we did. So yeah, it could be wrapped into sort of a generic framework. Now Mark's talking about LC Connect and upcoming talk today, I believe. So he'll probably have a bit more information. LC Connect is essentially designed for exactly this. It allows you to wrap third-party web APIs, REST APIs, using LiveCode without too much effort.
Well, that's great. I don't think there were any more. I don't see any more questions, and we are also out of time. So I need to wrap you up.
Yep, I'll put all the code up online so you can see it and review it later.
Yeah, I think people will be really keen to see that, and I know lots of comments about how interesting this is, so that's very cool. Yeah, so I'm going to shut this room down, and then I'm going to start again, and we have Kevin up next for his monthly report, which I know he's very much looking forward to. So I'll see you all again in a couple